Hi, welcome to this video on molarity of pure water. When we talk about molarity, it is conceived that it has to do with solute only. Today we will discuss the concept related to molarity and then calculate the molarity of pure water. In addition, for the benefit of biochemistry student, I will present briefly some unique properties of water as well. Due to its unique properties, water remains to be the most abundant solvent on the surface of Earth. About 70% of Earth's surface is covered with water. When it comes to human body, adult human body, in women it is 55%, in men it is 60%. It further goes up to 78% in infant body mass. Regarding the cellular content of water, it ranges between 70 to 80%, of which 33% is present in the extracellular spaces, whereas the remaining 66% is present in intracellular spaces. Therefore, water is the most important and abundant solvent in our cells, where it acts as a medium of reactions in our body. So water is not only the most abundant solvent in our cells, it also performs some important functions such as transport of nutrient, regulation of cell and body temperature. It also support the structure of biomolecules. In addition, it acts as a universal solvent where it supports the biochemical reactions in our system. As a biochemistry student or molecular biology student, you should know the unique properties of water. Water is not only abundant molecule, but it has certain unique properties, such as it is a polar molecule, it has partial negative charge and it has partial positive charge, due to which it acts as a dipole. And this property allows to make hydrogen bonding intramolecular. Because of that, it has a property of cohesiveness and also with other molecules as well, which impart it as an adhesive properties. Both are important for biological functions. For example, cohesive property is important for generating surface tension, which is important in our taste detection as well as in breathing or lung function. It also has high dielectric constant, which allow it to act as a solvent, and it helps in the dissolution of the salt. It also has high heat of vaporization, due to which it makes cooling effect on our body. It also has high specific heat. This is also responsible for cooling effect. In addition, it has high density. When I say high density, I am comparing it with the ice. So these are some of the properties of water, unique properties of water. The question is, does it have molarity? Yes, it has molarity and is also high, is very high as well. So we will discuss molarity and we will calculate molarity of water. But before that, I would like to go over certain concepts regarding molarity, moles, and Avogadro numbers. Before calculation of molarity, I would like to go over these concept of mole and Avogadro number, then molarity. Let us discuss mole. Mole is a quantity of measurement. It is defined as molar mass or gram molecular weight. For example, if you have one sodium chloride, 58 gram of sodium chloride is 1 mole. Glucose, 180 gram is the molar mass. Therefore, 180 gram of glucose is 1 mole. In biochemistry, molecular biology, we use smaller units. So when you weigh molar mass in gram, it is mole. When you weigh molar mass in milligram, it is millimoles. When molar mass is taken into microgram, it becomes micromole. And when it is taken into nanogram, this become nanomoles. and when the molecular or molar mass is in picogram, that quantity become picomoles. So these are the smaller units of mole. So the next concept is Avogadro number. It represents the number of particles present in 1 mole of a substance. These particles may be atoms, molecules, or ions, etc. Therefore, 1 molecule contains 6.022 into 10 raised to the power 23 particles of a substance. This number 6 into 10 raised to the power 23 particles is known as Avogadro number. This might be helpful in making certain solutions of drugs or reagent for your research work. So let us calculate the number of molecules in 1 gram of sodium chloride. Molecular weight is 58 gram. So number of molecules in 1 mole or 1 molar mass, which is 58 gram of sodium chloride, is equal to Avogadro number, which is 6.022 into 10 raised to the power 23 particles or molecules. Therefore, the number of molecules in 1 gram sodium chloride will be the Avogadro number divided by the molar mass, which comes out to be 1.04 10 raised to the power 22 molecules. So 1 gram of sodium chloride will have 1.04 10 raised to the power 23 molecules, 22 molecules, sorry. So now coming to the main part of the video, the molarity. Molarity basically tells you the strength of the solution. It is defined as the number of moles of a solute dissolved in 1 liter of solution. This distinction must be made very clear here, that you have to consider 1 liter of solution, not 1 liter of solvent. So basically, if you dissolve 1 molar mass of sodium chloride, which is equal to 58 gram of sodium chloride in 1 liter solution, that will be 1 molar. If you dissolve 180 gram of glucose, which is molar mass of glucose per liter solution, that will give you 1 molar solution. So this is about 1 mole. But let us see, if you want to make solution of not 1 molar, but let's say the fraction of molarity, and not 1 liter, but let's say 100 ml of solution, how you will make. So we will discuss that in next slide. So let us prepare 100 ml of 0.1 molar sodium chloride solution. So use the following formula for any substance, including sodium chloride. In this case, sodium chloride weight will be equal to molecular weight in grams times required volume, which is 100 ml in this case, times molarity, which is zero point 0.1 molar here, divided by 1000 ml. So you put these values here, ml will be cancelled out, and it comes out to be 0.58 gram. So you weigh 0.58 gram of sodium chloride, dissolve and make up 200 ml with water. You have to always dissolve in less than the amount you need, because there will be some volume expansion because of dissolution of the solute. So to counter that, to compensate that, you have to dissolve your solute in less volume and then make up with distilled water. So when you dissolve a solute in any solvent, there is always volume expansion, and that is due to intermolecular interaction between the solvent and solute. Therefore, to counteract or to take that expansion into account, you should dissolve the solute in a smaller volume, and after dissolving, you make up to the required volume with distilled water. So molarity of water. When it comes to molarity, we normally often consider that it has to do something with the solute only, not with the water. But you will know that water has molarity, and it is indeed is very high. So you have to have two pieces of information to calculate molarity of water. First one is specific gravity of water, means the weight in gram per ml. If you see the specific gravity of water is roughly 1, but there is slight difference range going from 0 degree 4 and up on coming up to 25 degrees centigrade. So it depends on the temperature also. Second piece of information you need is molar mass, which is molecular weight of water, which is 18 gram. So using these two pieces of information, you can calculate molarity of water. So let us calculate molarity of pure water at 25 degrees centigrade. Use the following formula. Molarity will be equal to the weight of 1 liter of water in gram divided by molecular mass or molecular weight of water, which is 18. So you put the values here. 997 divided by 18 at 25 degrees centigrade, which comes out to be 55.4 molar. So water indeed is very high molarity. Water has indeed very high molarity. You cannot have any other substance such with such high molarity. So pure water is the highest molar solution. It is the most concentrated solution having the highest molarity. So in the end, thank you for watching, and I hope it will help you to understand the concept. Please like it, share it, and subscribe it. Thank you very much once again. Take care and bye bye.